This session discusses two algorithms for searching in array data structure. They are linear search and binary search. So the problem is, given a key k, we need to search the linear data structure array. So this shows an example. We have an array data structure which has got 11 elements indexed from 0 to 10. So we have different elements, and in the case of linear search, the searching starts from searching starts from the first index, which is 0, and if the key is not found, it moves to the next index and so on. So if the search is unsuccessful, that is, the key k to be searched is not in the array data structure, then this needs to traverse all the elements of this array. So this is how linear search works. The linear in the linear search refers to the searching order which is linear. In the case of binary search, the searching is not linear but it is binary. Binary search is efficient when compared to linear search, but since it does searching in a non-linear fashion. So we will see how binary search works. Binary search is a remarkably efficient algorithm for searching in a sorted array. That is important. In order for the binary search to work, the array should be sorted first. It works by comparing a search key k with the array's middle element a of m. If they match, the algorithm stops. Otherwise, the same operation is repeated recursively for the first half of the array if k less than a of m, and for the second half if k greater than a of m. We will see it with the help of an example. So we have the key k to be searched equal to 80, two indices L, which is at the leftmost side, which is initialized to 0, and R, which is at the which indexes the rightmost side, which initializes to n minus 1, where n is the size of this array. So we have L equal to 0 and R equal to, in this case, 10. Then what we need to do is, we need to first find out m. M is the middle index. So in this case, that will be m equal to L plus R divided by 2. That is 0 plus 10 divided by 2. 10 by 2 is 5. So m equal to 5. So after this, what we need to do is, we will search whether a of m, our array is a of m equal to 80. So we can see that 40 is not equal to 80. So we already see that this is a sorted array. So 40 is less than 80, which means that there is no point in looking at the left side of 40, since this is a sorted array. So we need to look at only the rightmost part. So there is no need to look at the leftmost part. We need to just look at the rightmost part. So we will be adjusting the indices, like we can fix L as m plus 1. So L will be at the index 6, R stays the same, and again we need to calculate m. M equal to L plus R divided by 2. So in this case, it will be 6 plus 10 divided by 2. So 16 by 2 is equal to 8. So m equal to 8. So again we will be checking whether 80 equal to 88. So it is different. So 88 is greater than 80. So which means that there is no point in looking at the right of m, since it is a sorted array. So there is no point in looking at the rightmost part. So what we will be doing is we will be adjusting the value of r. So r will be moved to the left of m minus 1. So we will be fixing r here. Again we will be calculating m. So that will be 6 plus 7 divided by 2. So that will be 13 by 2. 13 by 2 we will be taking the floor. So we will be getting 6. So m equal to 6. So again we will be checking. So we can see that 80 is greater than 60. So which means that there is no point at looking at the left elements. So what we will be doing is we will be moving the L to the right. L to the right. So L equal to R equal to 7. So again we will be finding out L plus R divided by 2, that is 7 plus 7 by 2 equal to 14 by 2, that is equal to 7. So m will become 7. So again we will be checking whether a of m equal to 80. So we can see that a of m equal to 80. So search turns out to be successful. In that case m is returned. So this is how binary search works. The algorithm is known as binary search. The input is array a of 0 to n minus 1, array with length n and key k to be searched. So this is the algorithm name. Then we need to initialize the indices L and R. L equal to 0 and R equal to the last element, that is n minus 1, since we have n elements. Then we need to calculate the middle element and checking which is in a loop. The loop you can write it as while L less than or equal to R do, while L less than or equal to R, less than or equal to. If it is not, you need to exit. So in the while loop we have seen that we need to calculate the middle element L plus R by 2, which you need to take the floor. So we have middle element, then we need to compare. If key k equal to a of m, if it is equal, then what we can do is, we have already seen it in the last step, return the index m. Else if we have two cases, it is lesser or greater. Else if k less than a of m, k less than means we need to look for the left part. So in that case we need to only adjust the r. R will be m minus 1. We have seen it here. R will become, this R will become here. R will become m minus 1. R equal to m minus 1. Else, what we need to do? We need to assign L equal to m plus 1. First thing what we saw. L will become m plus 1. This is what it happened in the first step. So the search is unsuccessful. Return minus 1. So this is binary search algorithm. So for an array with large number of elements, so assume that we have a waste case. We we are trying to compare linear and binary search, and we have a waste case. Waste case is when the search key is not in the array. So in that case, if you see linear search, we need to and assume that we have a large number of elements. We need to start from the first element, move to the up to the last elements. Say assume that we have a 2 lakh an array with 2 lakh elements. In that case, each of these 2 lakh elements should be traversed. But if you are running a binary search, always you need to know that in the case of binary search, the array should be sorted. So in the case of binary search, you are finding the middle element, then searching. So the number of comparisons will be less, which means that binary search can finish the search procedure at a faster speed compared to linear search.